Welcome to ITE York University's first seminar of 2021. This is our February Seminar 1, The Future of Freight. Hope everyone had a good holidays. Hope everyone's had a good winter break, staying healthy, staying safe. So just a quick little thing as people sort of trickle in. We are the ITE York University student chapter. That's the student chapter of the Institute of Transportation Engineers, York University's community of transportation professionals. We host seminars, software tutorials, go on field trips and better days, do volunteering, social events as well. Some of these events are member exclusive. Membership is free, and if you'd like to sign up, you can sign up with us on campus groups if you're a York University student by scanning the QR code right here. For those of you who are not York University students, members of the general public, or other ITE members, you're completely free to watch our ITE seminar series right here on our YouTube live page. Be sure to subscribe if you haven't to be notified of any upcoming videos. I see that we have some people still coming in, so we'll wait a couple more seconds, but then we will begin with our three presenters for today, discussing the future of freight. All right, so we have three presenters today. We have Alia Galal from University of Toronto, Maddie Ewing from Pembina Institute, and Brian Sukai from Walmart Canada. So our first presenter for today will be Alia Galal, who received her Bachelor of Science degree in Industrial Engineering from the Arab Academy for Science and Technology in Alexandria, Egypt in 2017. She is currently a second-year PhD candidate in the Civil Engineering Department at the University of Toronto. Her PhD research combines freight transportation, human factors, and traffic safety as she analyzes truck drivers' skills and behavior using a truck simulator. The aim of her research is to develop a truck driver training module specifically addressing latent hazard anticipation skills with the goal of improving traffic and vulnerable road user safety in Canada and worldwide. So welcome, Alia.
Thank you so much, Tim. And thank you very much. I'm honored to be here today and present to all of you.
You can go ahead and hit share screen and just go ahead and share over me.
Okay. Can you see my screen now?
Yep, all good.
Okay. So hi again, everyone. I'm honored to be here and present my work to you. So my presentation today is mainly about my research topic. So it's assessing safety interactions between trucks and vulnerable road users. And for that, I'll be using a truck simulator. So I'll start right off with some background information and facts. So people have found that around 1.2 million pedestrians die and another 50 million get injured every year in road collisions only. So these numbers are very alarming. And on a more local scale, according to the Toronto Police collision data from 2006 to 2019, vulnerable road users were involved in 69% of fatal collisions. And by vulnerable road users, I mean pedestrians and cyclists. So about 56% of fatal collisions involved pedestrians and 5% of fatal collisions in Toronto involved cyclists. So these are very high numbers too. This picture this graph from the Ministry of Transportation in Ontario shows that although the road fatalities tend to decrease over the years, the proportion of pedestrian fatalities is strongly increasing. So this is also alarming. And concerning truck safety, research has shown that truck crashes are much more severe than other vehicle crashes. So for instance, many researchers show that pedestrians are on average 2 to 4 times more likely to die or to be severely injured in truck collisions. So researchers have found that there are many factors that contribute to truck vulnerable road user crashes. So they mainly categorize these factors into 4 different groups. So first, the location-related factors. So it was, for example, found that more truck vulnerable road user crashes happen at residential and urban areas, and especially at intersections. So yeah, it was also found that roads with a larger number of lanes or higher road speeds tend to have much more truck vulnerable road user accidents or collisions. Concerning the vehicle itself, a truck is, as you all know, difficult to maneuver and difficult to handle, and it has also many blind spots. So the lack of blind spot mirrors or the improper use of them leads to severe truck vulnerable road user crashes. And finally, the drivers themselves also sometimes lead to severe crashes. However, the strongest predictor for truck crashes is mainly the driver error, and that can be caused either by recognition errors, decision errors, or distractions. So I decided to focus here on one major driver error, and that is concerning hazard anticipation or the lack of hazard anticipation skills in truck drivers. So by hazard anticipation, I mean four things. First, it's the awareness of traffic risks and the threats to safety that are in the environment, in the driving environment. Second is that drivers have to visually search and then detect elements that might contribute to unsafe situations or threats to safety. Third, they have to predict what could happen out of these contributing factors or these latent hazards. And fourth, of course, they have to respond accordingly and in a timely manner to avoid such conflicts. So just for those of you who are new to latent hazard anticipation, by latent hazards, I mean the threats that could potentially happen, but they did not explicitly materialize yet. So the picture to the left shows that a vehicle or a driver that's approaching the blue area should anticipate that some sort of like a pedestrian or a bicyclist or a baby or anything could be passing in front of the vehicle or the large truck to the right, but it's here, it's latent or it's hidden. So a good hazard anticipation skill would make the driver anticipate or expect someone to be crossing. So a good truck driver or a good driver in general should be slower in this blue area. Since latent hazard anticipation requires a skill, so I've researched a little bit about truck driver training. In a survey study that has been done for truck drivers, most Canadian truck drivers involved in this study have claimed that the Canadian truck driver training standards are inadequate, and that's because the standards do not prepare drivers to drive in certain settings, such as mountainous or slippery roads, which are frequent. So these truck drivers that were surveyed, they recommended that more behind the wheel training should be included in the training rather than just theoretical and classroom training. In another study about simulator-based training specifically, it was found that this type of training received very positive feedback. However, people also suggested that it should be better implemented and the driving environment inside the simulator should be made more realistic so that it becomes more valid. So, based on everything that I have mentioned, I've developed my research plan with the aim of informing the development of hazard anticipation training and testing procedures for the sake of enhancing the safety of truck vulnerable road user interactions. And for that, I'll be using two interesting pieces of equipment. So first, I'll be using a truck simulator that's known to have a high reality and validity. So it's a quarter cab heavy truck minisim, and that is developed by the University of Iowa National Advanced Driving Simulators. So the University of Toronto is currently in the process of purchasing and installing one of those on campus. Alongside that truck simulator, I'll also be using eye tracking glasses that truck drivers should be wearing while doing the simulator drives. And these will help me or will help my team examine whether participants perform the necessary checks and do the hazard anticipation checks that they have to do. These glasses will also help in measuring the effect of distractions on truck drivers' latent hazard anticipation skills. So my research plan in 6 steps is as follows. First, and the current state we're at right now is doing some interviews to get more information and idea from truck drivers about what scenarios are the most dangerous or hazardous that whenever a pedestrian or a cyclist or a vulnerable road user is included. So based on this and of course some literature review, I'll be creating or developing some simulator scenarios. Then participants like novice truck drivers will be recruited to do some test drives using the simulator. And out of the data that we'll gather from the truck simulator and the eye tracking glasses, we'll have a little bit of idea about the most common mistakes or the lack of skill, where exactly this lack of skill comes from. And based on that, we'll develop some training and testing modules specifically for hazard anticipation skills. And hopefully these modules will be put into practice after validation. So the expected contributions of this research plan are that this will be the first study to examine truck drivers' vulnerable road user related latent hazard anticipation skills. And out of this study, we are hoping to get or to develop training and testing procedures for improving this skill specifically. So the long-term plan or the long-term goal of this is, of course, to enhance the anticipation skills of truck drivers and therefore also improve truck safety or vulnerable road user safety in Toronto and hopefully worldwide. I'm just about to finish, so just some notes about my whole presentation today. So I just mentioned that truck crashes with vulnerable road users specifically is a very serious problem, especially here in Toronto and in Ontario. And the strongest predictor for such crashes is driver recognition errors, decision errors, and distractions. So yeah, and based on truck driver training standards in Canada are still inadequate. So therefore, I decided to improve a specific skill, which is hazard anticipation skills. And by that, I will and to do that, I'll be using a truck simulator and eye tracking equipment. So I reached the end of my presentation. Here are the references I used in the first couple of slides, and I'll be more than happy to hear any feedback or any recommendations about anything I've just mentioned. Thank you so much again.
Thank you very much, Alia. A round of applause for our presenter. Are there any questions specifically for Alia on what she just presented? If you're watching on YouTube Live and you have a question, please toss it up in chat and I'll relay the question. No one?
Sorry,
go ahead. Go ahead, Tanvir.
Can I go for the question?
Yep, go ahead.
Yeah, with your permission, I'm proceeding. Yeah, hi Alia, it's a really nice presentation and nice topic you are progressing. I have a quick question. Like, what is the percentage of mountainous road in Ontario? I was trying to find out that. Can you let me know?
I'm not pretty sure about the exact percentage, but I might search for that and maybe I'll let you know if I do.
Okay, that should be fine. No worries. Okay. And I have one more query for you. That one is for the eye tracking. What is the purpose of using that eye tracking technique in this latent hazard identification process? What is the purpose of that?
Yeah, so we'll basically be using eye tracking glasses just to track the eye movements and the frequencies and length of fixations of the truck drivers, just to know if they look at the right place in the right manner and they give areas of importance the right amount of concentration or not. So it yeah, the eye tracking glasses will give us much more details about eye tracking movements and where truck drivers fix their attention or point their attention while driving.
Nice. Okay, I will actually look forward on to that. This eye tracking use of eye tracking technology to understand the behavior and to understand how we can incorporate that in our industry. That would be really nice to see. Thank you so much, Alia.
Thank you. Thank you.
I'm handing to team again.
Yes, thank you, Alia, for the great presentation. I'm actually also curious, not just about eye tracking, but also head tracking. And just to give everyone a bit of background on myself, if anyone follows the ITE page or the IT Campus Group's events, last week I did a virtual truck drive in a, I guess, more consumer grade video game style software. And I don't use eye tracking, but I actually use head tracking, which keeps an eye on where my head is looking, so it changes my screen in real life, or my virtual screen. So are you also going to be doing head tracking as well when you're doing your study, to also see if your drivers are turning their heads to see where they're looking?
Well, I would love to do that. However, the angle of sight is limited in a truck simulator, so I think it's 140 degrees only. So I don't think head tracking would be necessary in that case. Like they can't do a 180 head turn. There's nothing to see.
Mm-hmm. True, because you just have the, like,
Yeah,
as you're showing, the
limited view.
two
Yeah.
panels.
Yeah.
True. That is a very good point. It's much better than just having a single screen to stare at, I can tell you that. If you're ever looking for someone who's a complete amateur at driving trucks to test out your simulator, let me know. I'd be very happy to test that.
Thank you. I'll definitely contact you. Thank you.
Any other questions?
Yeah, Tim, if you don't mind.
Yep, go ahead.
Alia, first of all, I'd like to say excellent presentation. So the only question I have, you're like mentioning that you'll look through the pattern of the drivers, like what are they seeing at the real time with the help of your eyeglass. But like my question is, are you also taking into account of the compliance, reliability of the truck drivers into account? Like what happens if the first driver follows the rule, like the way or the side of the road they should be looking at, but what happens if the driver following him closely doesn't follow it? Are you taking that into consideration, like the compliance reliability factor?
Sorry, I didn't understand the question very well. So you're talking about other drivers in the environment?
Exactly, like the ones that are following those driver, like the compliance reliability.
Well, I didn't think about the trucks that follow, but in order to have good hazard anticipation skills, the driver himself should be aware of everyone in his surroundings or in his in his area. So I think the drivers, of course, in front of him and both on the sides will also be affected, or he should be aware of them, but not the one leading or following him.
Okay.
I don't think I don't know how to measure the effect of the truck drivers that are behind him.
Okay, so yeah, I was just like asking what happens like if like you're posing a certain model that the driver should look at this side while crossing a certain section of the road, but what happens the driver you're like following the leading vehicle doesn't follow that particular rule, like they're not complying to that particular like action you mentioned in your research. Like what are the chances that they will comply to the rule, the compliance reliability factor?
So you're talking about the vehicles that are behind the truck
Yeah,
driver
like
that
if
is
they're
chased,
following,
right?
yeah,
Yeah, so if the driver himself does anticipates the hazards in a timely manner, then he might press the brake pedal in a timely manner, and hence the followers should also have enough time to react and to avoid the collision with him.
yeah, perfect. Yeah, that's what actually I was wanting
Yeah.
to talk about. Thank you.
Thank you.
I think I'll actually jump in with a suggestion. If you've not quite reached the stage of determining scenarios yet, it actually might be a good idea to potentially incorporate a scenario where instead of the driver driving the simulator is in the front truck, he's in the following truck. So are they maintaining proper following distance or braking distance so that if the truck in front slams on the brakes suddenly in compliance, how does the driver behind react?
Yeah.
That might actually work.
Yeah.
Yeah,
That's
like
a great
you
suggestion,
mentioned,
yeah.
gap acceptance might be, like important factor here.
Yeah, you're right. Yeah.
Plenty of good ideas all around. This is a really interesting study. I'm looking forward to seeing what comes out of it. Thank you very much.
Thank you.
All right, so we're going to go ahead and I'm going to share my screen back because we have our next presenter coming up. Next up is Maddie Ewing from the Pembina Institute, Canada's leading clean energy think tank. In her role, she leads research and engages key stakeholders to better understand the barriers and opportunities associated with a wide range of low carbon solutions for Canada's on-road freight sector, including demand management, fuel switching, and fuel efficiency practices. Prior to joining the Institute, Maddie completed a Master's of Applied Science degree at the University of Toronto in the Department of Civil and Mineral Engineering, where her research focused on evaluating low carbon alternatives to diesel fuel for long-haul trucking in Canada. So welcome, Maddie.
Thank you so much for that introduction, Tim. I'm really happy to be here today. You know, as you heard in my bio, I recently graduated my master's at UofT, and definitely benefited from, you know, seeing presentations and seminars just like this. So I'm really happy to have the opportunity to return the favor. And I'll just go ahead and share my screen here. Perfect. And can you just give me the okay that you can see that?
Yep, all good.
Perfect. Okay, so I'm going to be presenting, not presentating, but presenting on the topic of urban freight electrification in the Greater Toronto and Hamilton area. So I'm here today representing the Pembina Institute, where I work as a transportation analyst. For those that don't know, Pembina is a nonprofit think tank with offices across Canada. We advocate for strong, effective policies to support Canada's clean energy transition. So our work is primarily generated through research and analysis, as well as stakeholder consultation. And our work on freight in particular is geared at supporting the industry and governments in achieving decarbonization of freight while building more resilient communities. So at the Pembina Institute, we see freight as one of the next frontiers for climate action. Transportation represents a quarter of Canada's greenhouse gas emissions, and freight represents an increasing share of this. So in fact, at its current rate, it's expected that greenhouse gas emissions from freight will surpass those of passenger vehicles by as soon as 2030. As urbanization, economic activity, online shopping, and the demand for same-day home delivery increases, the number of delivery trucks and vans on the streets of our cities is growing. And as we've seen, the COVID-19 pandemic is prompting more Canadians, probably like yourselves, to buy online. which will only escalate truck traffic in urban areas. So now is the time to consider what the proliferation of delivery trucks is going to do to the air that Canadians breathe and the impact those vehicles are having on climate change. So addressing the emissions impact of freight activity in our cities will require a multi-pronged approach. And while it's not the only approach, we see the electrification of urban last mile deliveries as a key part of the solution. So as I'm sure most of you know, in areas where the carbon intensity of grid electricity is low, electric vehicles can play a key part in reducing greenhouse gas emissions and improving local air quality. But urban delivery vehicles are also particularly well suited for electrification. These vehicles travel short distances, on average less than 100 kilometers in a given shift, and typically return to a central depot at the end of the night, so they can easily take advantage of overnight charging when electricity rates are low, and also when the carbon intensity of electricity production tends to be the lowest. So research from the California Air Resources Board, or CARB, and CalSTART, which is another nonprofit leading a transition to zero emission commercial vehicles, have shown that the urban delivery segment is in fact expected to be the next wave of electrification. So as you can see on the slide here, we had transit vehicles in the first wave of on-road electrification, and wave 2, they predict will be delivery. So lessons learned from early battery electric transit bus deployment can help advance electrification of this urban delivery vehicle market. So we've already seen several major North American companies signal their interest in electric urban delivery vehicles. Amazon, UPS, and FedEx have already placed substantial orders for electric cargo vans. Purolator is testing low-speed electric vehicles on delivery routes actually here in Toronto and in Montreal. And international companies like DHL and IKEA have committed to full electrification of their delivery fleets within the next 5 to 10 years. But we're also seeing a shift in manufacturing. So vehicle manufacturers have signaled their interest in electrifying the last mile. Ford has officially launched an all-electric version of their ever-popular transit van. You probably see these vehicles all over the streets of Toronto right now. GM actually just last month unveiled their EV600 cargo van. Mercedes has released their e-Sprinter in Europe, and several other manufacturers, including Canada's own Lion Electric, have announced plans to or are already manufacturing electric vehicles suitable for urban deliveries. So despite interest from urban delivery companies and commercial vehicle manufacturers, barriers to urban delivery electrification remain. So first, there are limited and inconsistent zero-emission vehicle policies and supporting infrastructure to help businesses integrate and scale commercial electric vehicles. Second, vehicle costs and demand charges on businesses' utility bills can be prohibitively high. Third, limited public charging infrastructure exists, and while depot charging is often preferred by these fleets, the installation of private chargers can at times be expensive and time-intensive. Lastly, businesses need reliable resources and information to navigate, adapt, and overcome the changes that are required for the shift. So what are we doing at Pembina to help overcome some of these barriers? We recently launched a project funded by the Atmospheric Fund to do sort of a three-pronged approach to this issue. So first, we're going to build the business case for urban delivery fleet electrification in the GTHA. Two, we're going to develop an action plan for urban delivery EV deployment. So what steps do these businesses actually need to take to deploy electric commercial vehicles? And three, establish a zero-emission vehicle supportive policy guide. So what policy supports are needed to bridge the gap between traditional internal combustion engines versus electric vehicles? So step one is building the business case. So we're going to work with researchers and we are working with researchers at Canada's National Research Council to model urban delivery vehicle operations in the GTHA and quantify the expected reductions in greenhouse gas emissions and fuel costs and identify charging infrastructure requirements. So our modeling work has centered around the development of 13 scenarios that have been developed using data obtained from Geotab, which is a telematics company, which documents the actual operation of door-to-door delivery vehicles in the GTHA, as well as some of the results from a survey that we conducted with major urban delivery companies back in the spring. So we'll be creating scenarios that represent a range in vehicle operations, such as a light delivery day, perhaps not during a peak time of the year, or one during the busy holiday season over Christmas, where external temperatures might be as low as -20. For each scenario, we'll be modeling the operation of a single vehicle model. So we've selected a cargo van based on feedback from our businesses that we engaged. Our model also takes into account logistical considerations, like how much downtime each vehicle has between shifts, which helps to inform charging patterns. And through the model, we'll be able to identify estimated electricity costs for charging, greenhouse gas emission savings compared to a gasoline baseline, vehicle battery size requirements, as well as the charging infrastructure requirements. So whether or not they'll need level 1 chargers, level 2, or DC fast chargers in order to be ready for their next shift. So these outputs will ultimately inform the development of a business case and also the action plan for EV deployment. So step 2 of our project will involve the development of an action plan, as I mentioned, and what we want to do with this is equip businesses with the resources and information that can help them integrate and scale up electric fleets right here in the GTHA. So we want to clearly articulate the steps that businesses need to take in the near to midterm to effectively deploy EVs, including actions pertaining to vehicle procurement, infrastructure build-out, utility engagement, to name a few. So we've actually been engaging a number of the major utilities here in the GTHA, including both generators and local distribution companies, as well as fleets that have experience with EV deployment to identify some of the key success factors, as well as some of the common obstacles and potential solutions to those obstacles. The final step of our project is to establish a zero-emission vehicle supportive policy guide, in which we'll identify and advocate for policies to reduce barriers to electrification. So, what we might find in our business case is that, we've not yet reached a parity with internal combustion engine vehicles, and that we may need some supports in the interim before those EVs reach scale. So these policies are going to they'll span a range of different mechanisms. And some early solutions that we've identified and definitely support include, municipalities developing zero-emission vehicle strategies for commercial vehicles. So while municipalities tend to have zero-emission vehicle strategies for passenger vehicles, these often exclude the commercial segment. Another policy mechanism is expanding the green vehicle license plate program to commercial vehicles, which grants green vehicles, so things like battery electric vehicles, access to high occupancy vehicle lanes. Additionally, establishing low emission zones in cities in which only vehicles below a certain emissions intensity threshold can access. Curbside management tactics such as preferential loading zones for low or zero emission vehicles. Investments in charging and refueling infrastructure, as well as, very importantly, skills training for maintenance workers and operators. So findings from each of our analyses will be summarized in 2 final reports, one aimed at businesses, so that will include both the business case and action plan, and one for policymakers. We'll also be hosting a webinar in spring 2021 to discuss with key stakeholders how we can accelerate urban freight electrification here in the GTHA. And finally, we'll be looking to engage key policymakers to discuss the implementation of the zero-emission vehicle supportive policies that we identified in the policy guide. And with that, that is it from me. So thank you so much for your time today, and feel free to follow up with any questions.
Awesome. Thank you very much, Maddie. Any questions for Maddie? I think I'll kick it off with a question of my own. You mentioned V1, V2, and DC fast chargers. What's the difference between the 3?
Yeah, so level 1, level 2, and DC fast charging they correspond to different speeds in charging. So a level 1 charger, you could literally just plug it into a typical wall outlet. And so it reflects the voltage. Level 2 is a little bit higher, so you're going to actually need a dedicated installment to transmit that voltage to the vehicle. And then a DC fast charger is the fastest and most expensive charger that can, potentially recharge a passenger vehicle, for instance, in 30 minutes or so. So it essentially just corresponds to the speed of charging. And so for some fleets, they need potentially to charge faster in order to have their vehicles ready for their next shift. But what we found here is that because so many of these urban delivery businesses have returned to base operations where their vehicles remain overnight, they actually don't need to charge very quickly. And this results in pretty significant cost savings for them, not only in the infrastructure updates that are required, which are minimal or smaller in this case because they don't require greater amounts of voltage here, but also because if they're charging at a slower speed, they're seeing lower peaks in their electricity consumption, which translates to lower fuel costs as well.
Awesome, thank you very much. I guess then the example that I'm thinking of from Montreal, where they have their electric buses running, they have a gigantic overhead gantry with a pantograph that descends from the gantry to charge up their electric buses. So I guess that would be an example of a DC fast charger then, because like very large.
So yeah, so that's just overhead charging, which is a different way to charge the vehicle. So rather than charging it by sort of plugging something into what almost is usually like traditionally the gas tank, I guess, on the side of the truck, we now have chargers in that same place to sort of mimic that. So instead of plugging a charger in there, they're actually charging by connecting overhead. So you can, and I'm not super familiar with the offerings of the technology, but I imagine that you can have overhead charging for a number of different speeds. In the case of those buses, because they're kind of going under there very quickly during their routes or in between routes for limited downtime, presumably those chargers are fast chargers because they do need to see that quick sort of turnover.
That's very true. Awesome, thank you. Any other questions for Maddie? Hearing none. Tanvir? No? Okay.
No, team, not right now. I will have,
Perfect.
I'm thinking.
We also will have a bigger question and answer session at the end. So if you think of any other questions, feel free to let us know at the end. All right, I'm going to go ahead and share my screen back to introduce our last speaker of the day today. And that would be Brian Sukai. He is the Senior Manager of Transportation Innovation and Planning for Walmart Canada. He's held progressive positions within Walmart over the past 17 years and has demonstrated a proven track record of successfully leading and implementing various business solutions with cross-functional teams from a true end-to-end standpoint, while also focusing on driving continuous improvement initiatives and developing people. Brian holds a Bachelor of Commerce degree, double majoring in both accounting and management from Ryerson University. That's the Ted Rogers School of Management, complemented with the School of Business, Lean Supply Chain Management, Harvard Business School, Leadership, and a Lean Six Sigma Green Belt certification. Wow. Welcome, Brian.
Afternoon, everyone. Thanks for having me, Timothy. Really appreciate it. Great job, Alia and Maddie, on the previous presentation. I guess I'll kick things here off. Let me just share my screen. Yeah, can you guys see this?
Yep, good to go.
All right. So I'll cover, I guess, our smart transportation strategic initiatives for Walmart Canada and give you an overview in terms of the direction we're going and various levels of input and output, essentially. So, okay. So here's kind of our strategy in terms of, I guess, our 5-year plan in terms of what we're focusing on. So as you can see, sorry, just give me 1 sec. I think things skipped here. Okay, sorry about that. All right. Oops. Okay, perfect. So this is kind of our strategy over the next 5 years in terms of what it is we're focusing on. So the one that stands out the most is an alternatively powered fleet. So we made it clear that by 2028, we as Walmart Canada, we want to be 100% sustainable with regards to our trucking operation. Walmart Global as a whole, their goal is not as aggressive. They're aiming for 2040, but for us, we have a more of an aggressive goal there. So for us, we've gone forward. We've made a partnership with Tesla. If you were going back a couple years, we had an initial order placed of 40 units. And last year sometime, I spent, looking at, where we need to be, what we need to position, and working with our leadership team, we increased that order to 130 units. So as far as we know, in Canada, that's the second largest order that's been placed with Tesla. and we're still looking at potentially growing the rest of our fleet as the years come. We do have a strategic plan in place. We are working with other OEMs, trying to understand what they have available, as well as looking at other types of alternative fuel as well. So that's touching on our alternative powered fleet. Then in terms of other things we're doing with regards to smart transportation, also recently, last year, we started our blockchain element. So working with a company called DLT Labs and partnering with our carrier partners to ensure our payments are done through a blockchain method. And we've had great success with doing that so far. In terms of planning, sourcing, and delivery, looking at kind of taking what we do today and kind of transitioning it to something more smarter, essentially that's sharper going forward as we move in our network. So looking at automated carrier payment processes, sharpening our pencil on that, looking at our scheduling, so tightening up on our outbound schedules, and giving visibility to different areas and groups such as store operations with regards to transportation, so they can make better store decisions, labor, landing, and so forth. And then finally, on visibility and support, we recently started using more of our ForeKites technology. So using that to see more real-time data in terms of tracking. We might have inbound loads that are tied to promotions, and kind of tightening that up so we can get an understanding when that's coming in, plan our labor better. And on the outbound side as well, looking at where these loads are. There could be strategic loads placed with regards to promotions and planning store labor. That's key as we kind of tighten things up in our operation. So as I mentioned before, we bumped our order up to 130 units. For us, we're very passionate about this. We've had a lot of interest from outside with our carrier partners and other Walmart groups, trying to understand why we made the decision, how does it fit within our network. Our network's very unique here in Canada. You kind of look at the coast-to-coast map. A lot of the population in general is on the southern side where our borders are, and that's essentially where our stores are located as well due to population density. And looking at our weighted average distance and how we operate, felt that going forward with this model with Tesla was the right fit for our business. It may not work out so with other retailers or other trucking companies based on their operation, but for us, we felt this was the right step in our direction, essentially. So why we chose this truck, an individual presenting earlier kind of hit on it. Safety is a big factor of how we operate, especially with trucking. I mean, if you look at, Ontario in general, Ontario is a trucking capital of Canada, essentially, if you want to put it that way, especially that 401 corridor. So safety is a key factor. We do have one of the top safety records already with our fleet, and we want to keep growing that. So this truck, based on what it's equipped with, we went forward with that. That was a huge decision factor for us. We want our drivers to be safe. We want other drivers on the road to be safe as well. So that was one huge thing there. Also, the greenhouse reduction as well. We have very aggressive targets over the next 8 years within Walmart Canada. So we've kind of mapped out where this is going to be positioned and how that's going to play out. So we've kind of have this implemented to kind of work towards those goals and objectives, essentially. The diesel fleet we have right now, it's fairly efficient already as it is. We have done a few things to make them more efficient, more on our trailer side. So modifying our trailers with different aerodynamic devices, such as skirts, and we're now testing rear fairings and front fairings as well. So those initiatives will only help with regards to our greenhouse gas emission reduction. And then specifically on these trucks as well, if you look at the maintenance factor, with the electric truck, there's less moving parts. We'll have more of these trucks on the road, they'll be out of service less. So that's a huge thing as well. Because, when a truck is parked, it's essentially, it's not, it costs $15 essentially. We want it to be on the road as much as possible because we do operate our fleet or try to operate it as much as 24/7 as possible. With regards to charging, that's been, an opportunity in determining a strategy in and around charging. A few things to factor in is, you can have as many trucks as you want, but you're tied to the charging restrictions available. We're looking at kind of our network today, and more specifically, an actual postal code. You have to really focus in on that factor. So for instance, you might have X amount of charges running at the same time, and you could be pulling, 4 megawatts of power. Well, one, does the municipality have that to you? Two, is that even available? And three, does that impact your DC? As our network as a whole, we're looking at converting and building our DC network to be automated. And when you're building, those types of distribution centers, they use a lot of electricity. And in working with municipalities, they have a 20-year plan in terms of how that specific postal code is going to look with regards to hydro and electricity. So, you have to have these discussions now for when we want to have increased electricity running, by 2028 or 2030 to get your position on the map. One great example is, we're building a brand new DC in Surrey. It's in, I guess, a new distribution area. And while we're kind of the first ones there within that area, there's other companies that are going to be building along that street. So if our plan is, today we want to use, like, for example, 3 megawatts of power, but by 2028, we're expecting to use 8 megawatts of power. Well, BC Hydro needs to be aware of that because, company X, Y, and Z might be planning the same thing. So there's limited power within that postal code. So that's a key thing to work that out with, the government, the different levels of government. The great thing is they're starting to get into this. So, Hydro One, BC Hydro, Quebec Hydro, they're starting to have provincial plans and benefits available to different organizations with either grants or specific energy rates just for trucking to help build this industry. So we're really looking forward to that, and that helped play a key factor in terms of partnering with different individuals to get that going. And then specifically with this truck, it's been proven already in their existing passenger vehicle fleet. The technology works. We look forward to getting one of the first trucks on the road here in Canada. And it's just a matter of getting that infrastructure together with our groups. So in terms of us, with regards to Walmart Canada, we want to build a best-in-class supply chain. So with specific to trucking, looking at an electric fleet or all other alternative fuels as well, with Tesla and with other OEMs that meet or fit the criteria that we need to manage our business and meet the expectations of our customers as well. And looking at the way we operate and build our DCs as well. Running as efficient as possible, reducing our greenhouse gases. Renewable energy is a key one as well, whether that's solar or wind power, incorporating that as much as possible. Because we do want to reduce our carbon footprint. Like I mentioned before, we want to be 100% renewable by 2028. That's our huge goal and objective there. And the other main thing I mentioned before, safety. That's a key thing in our operations. Our operations leaders are measured by safety, different elements or KPIs. So that's the key thing. And this truck really complements that with regards to our goal and our objective there essentially. And that's pretty much it from my end. So thank you guys for your time, and I'm totally open to any questions or comments or maybe from the group.
Awesome. Thank you very much, Brian. Any questions for Brian? I think I'll kick it off then. Okay, I'm going to go ahead then. So my question is more around sort of opportunity for charging these vehicles, because I understand that your trucks are generally on the road quite a bit, but they also spend a lot of time, I guess, on docks loading and unloading. Is that sort of the opportunity that you're looking for charging, or is it going to be more of like an overnight charging idea instead?
It's definitely going to be, to start, an overnight solution. The infrastructure, we do have a lot of drops and pickups, whether that's at suppliers or even our stores. But that type of infrastructure is very, very expensive. So to start, we like to move forward. We base the initial model off of charging overnight, or that one-time charge. The mileage we expect to get, the trucks, right now you're looking at anywhere between 400 to 800 kilometers per charge. So based on how we operate, and if you're looking at a driver, if they're on a shift for 12 to 13 hours, when we mapped it, the amount of charging is sufficient to last for the entire shift. And with the charging times, I mean, as battery technology picks up, I mean, you can charge one of these trucks, you know, they're talking like 60 minutes, maybe 92 hours. And then it has that full charge if there's 10% battery life left in. I mean, obviously over time, the battery degrades due to different elements in the weather and age. So that will all change. But as battery technology picks up, we're expecting the OEMs to really take that into consideration. It's definitely going to be a learning process for sure in the first 48 months with the OEMs, because when you're talking passenger vehicles and long haul trucking, you know, you've got 4,000 pounds and then you've got, you know, 80,000 pounds. That's going to really change things, and it's going to be a learning curve. So we're definitely looking forward to working with the OEMs and sharing that data with them so they can improve their OEM offering and for everyone. And, you know, by the time you're looking at 2030, on the greenhouse gas emission side, you should see a huge reduction across the board with, you know, all the major retailers and trucking companies combined.
Awesome, thank you. And I guess the other thing is, once you have that initial infrastructure, particularly if you have like at distribution centers, I guess that also lays some of the groundwork potentially for future like longer haul as well. Because I think I saw that these were for day cab applications, right? So just within more localized areas.
Yeah, that's correct. Our fleet that we operate within Walmart, it's 100% day cab. We have played around with doing some long haul activity with our own fleet, but as we move forward, our charging infrastructure, we want to be available for our third-party partners as well as we grow, because we do utilize third-party carrier partners to do those long haul, you know, 1, 2 day, even 5-day routes. So, I mean, if they're there and they're waiting, you know, for paperwork or whatever the case is, they can plug in for those 15, 20 minutes if they need to, and, you know, plug in and charge up as they need. That will probably come later on in the future once we kind of get everything settled with our charging infrastructure and build it up from there.
Awesome. Any other questions for Brian?
Yeah, hi Brian.
Yeah.
Great presentation. Oh,
Sorry, go ahead.
okay. Great presentation. I just have one quick question. So as like technology advances and autopilot increases with these trucks, do you think that the need for these drivers will still be there?
Absolutely. I mean, we've looked at autonomous trucking here in Canada, and in speaking with different consulting groups and carrier partners, there has to be a level of confidence on the road with the passenger vehicle side, and we're not there yet. I mean, that's still years away for, you know, autopilot to be on your actual passenger vehicle, and it's fully autonomous. I mean, that has to be done first before, you know, we get into the trucking aspect. And even then, there is a pilot that the Ontario government can do today, I think with a Class 6 vehicle with regards to autonomous, but there has to be a driver in the cab. The US is a bit more advanced on it. They're doing like full routes, but even then the restriction is that there still has to be a driver in the cab. And it's going to be a number of years before you see a driver not in the cab, or probably ever. I mean, with things with road construction and different weather patterns we experience here in Canada, I mean, the technology for autonomous has to really take off and be advanced, and it has to be 100% level of confidence on the safety aspect for there not to be a driver ready to take the hand of the wheel should there be an upcoming incident or some type of reaction that needs to happen. It's definitely going to be quite a number of years for that to occur for that instance.
Thank you.
Great question.
Any other questions?
My question for Ran is, I understand in your motivation towards the automation. I'm just wondering that whether you guys have done the investigation on the different roadway infrastructure, like not I saw you have done some in from Walmart. You guys have done some study with the grade steep grade section as well. I'm just wondering how much fuel saving we may have on those area if we make the vehicle in automated.
Just clarify the question. You're asking what type of benefit we would get through autonomous trucking? Is that the ask?
Yeah. For the steep slope section specifically.
For slopes like on the highway?
Yeah.
I mean, through automation, I mean, or autonomous driving, I mean, we're looking at, you know, the different gradings on the road and so forth. I mean, with autonomous, if I'm thinking correctly, I mean, the drive based on the software we've been kind of given the heads up on, the software will be able to predict or know essentially that, hey, you know, 600 meters driving on this path, it's going to elevate by, you know, 30 or 40 degrees or whatever the case is. So it might help hold that acceleration level steady. And then if you're doing that, the fuel or your electricity consumption would probably be, you know, better versus if it was a manual driver. They may accelerate faster and just kind of ease off and then accelerate again and then ease off. I mean, each driver, their habits different. If you think of your own vehicle today, you know, you have cruise control. And if you leave it on cruise control, if you're driving on the 401, it's going to keep it there at, say, 100. And if you're driving, you know, up that high section going up towards the DVP, you'll see it revs higher, so you're using a bit more gas. But if there was no cruise control, I mean, depending on how your driving habit is, you know, you might want to floor it a bit more than what your cruise control option would do, and you might consume more gas. And you'll let it ease off a bit, and then you'll floor it a bit more. Each driver habits.
Yeah, I understand that point actually, Brian. I just wanted to know that if we go to the ego mode and again need to accelerate, okay. So in this transition, for the automation, whether we will get the full fuel consumption benefit, what we are saying, or it will be reduced than what is the current scenario.
It's definitely going to be improved or reduced. Based on what we've been shown, there is a benefit, and it's definitely a reduction versus a manual or in-person cab driver.
Okay.
Yeah. There's also the safety impact or benefit we've seen as well. I mean, drivers, as perfect as you might think it is, drivers do get distracted, unfortunately. But with autonomous, I mean, it's programmed. There's no distractions or whatsoever. So there are, you know, quicker reaction times and so forth to avoid any accidents or incidents as well. There's that benefit too.
I see. Thank you so much, Brian. It's really nice to
Thank you.
and have a good answer for me. Thank you. It was a really nice presentation.
Thank you.
All right. Any other questions for Brian, or shall we open up the floor to everyone? I think I'm going to open up the floor to everyone, so if everyone could come back in. And do we have any questions for perhaps all of our presenters? Hearing none. So this one actually goes more towards also sort of driver safety and the new Tesla truck in particular. I noticed that one of the things that the Tesla does is it's moved the driver from being offset to the center of the vehicle. So this sort of goes into both Alia and Brian, for both Alia and Brian. What do you think the effect of moving where the driver sits? What do you think the effect of that might be for, say, sight lines, or how a driver might actually have to drive the truck? Do you think there's going to be any differences?
It's definitely going to be a learning curve for sure. Based off kind of what we were told from the OEM it was a learning curve, but it was essentially the drivers found it to be a bit more comfortable. It improved their line of sight of the road, and their mirror positioning based on how the truck was designed. It's actually in fact better and kind of your day cab design today. That's kind of how we were told. I mean, we have yet to get our hands on one. I mean, my boss definitely, he went down and took one for a spin. And he said it definitely was a learning curve, but after, you know, a couple of rounds on the track, he said, yeah, he felt a lot more comfortable for sure.
Yeah, and I think also changing where the driver sits changes also the blind spots of the truck, and that may need further adjustments of the mirrors, and for the driver to be able to detect all hidden or unclear areas of the truck. So yeah, it's going to change a lot of things.
I think one other nice thing about the Tesla truck in particular, it looks like that hood is very sloped. It's not as distinct as your classic North American truck. So I'm betting that's going to definitely improve sight lines out the front.
Yeah, definitely. It's good that you mentioned that, because with the way we operate our trucks, we operate in a lot of urban environments. So I mean, very dense areas. If we look at our existing diesel fleet today, we had previously the Volvo VNL, and then we changed to the Volvo VNR. And that truck, the nose is a lot shorter. So if you're driving, you can see actually someone in front of you walking at a crosswalk with the new trucks, whereas the older truck, you couldn't see that. And with the Tesla truck, it's even better. So it's a lot safer for our pedestrians, and even for the driver themselves, they'll feel a lot more comfortable. Sure.
Awesome, thank you. Any other questions? Okay, hearing none. So in that case, could we just get a round of applause for all of our presenters? Thank you very much. All right, so before we go, a few other things coming up that people should be aware of. We've got a few other events going on. So first off, if you missed part or all of this presentation or any of our previous seminars, we have archived them for you right on YouTube. So check out our YouTube page to see the ITE seminar archives. This will take you back through all of the, there it goes. This will take you back through all of our previous seminars. You can re-watch them again on your own time as you please. We have our annual general meeting tomorrow, February 2nd, from 6:30 to 8:30 p.m. We have a little Gather Town site set up where people can sort of just drop in, wander around, chat with everyone, because come on, let's face it, it's been almost a year since we've actually seen each other and got a chance to sort of chat one-on-one. So we've got a neat little IT railway station set up for us to go in and explore. That'll probably run from about 6:30 to 7:30, followed by our AGM actual meeting and presentation, where we'll go over what happened in the year that was 2020. If you're interested, once again, you can scan the little QR code here, which will take you to our campus groups page to sign up, or you can just check us out on campus groups and find the link through there. Looking forward to seeing you. Also, we are hosting the ITE International Student Leadership Summit, February 19th, and helping host, I should say, in cooperation with ITE International. This will be going on February 19th and 20th, and early bird registration deadline is this week on the 5th. It's 2 days full of transportation seminars and other events to help you become a leader in the transportation field and in your careers. If you're interested, you can check out itestudentleaders.org to sign up and to check out more information. And finally, our event that we are running as part of that SLS is a Career Connect session, which is very similar to the Career Connect sessions that are held by CITE on YouTube. We do need some volunteers for that. So if you're interested in volunteering and being part of a Career Connect session, please scan that QR code in the bottom to fill out the sign-up form. And we'll let you know 3 lucky winners who will be able to participate. All right, and with that, I believe that brings us to the end of our seminar for today. Thank you so much for coming out and taking a look at what we have to offer today. As always, stay healthy, stay safe. Something coming up in chat. Thank you all our presenters, and thank you to all of our audience. Stay healthy, stay safe. We'll see you in the next one.